Alright, so this is the video review for exam number 3. These are all the practice problems you can see on exam number 3. This deals with chapter 6 and the 2 sections in chapter 11. So, the first parts of chapter 6 involved operations of polynomials, right? So, let's just look at these examples here. So perform the following indicated operations for each problem. So all I'm doing is I'm just doing the operation that's indicated. So since I'm adding here, right, all I have to do is add the like terms together, right? So the a squareds are right here. The AB terms are right here. And then the B squared terms are right here. So by combining their coefficients together, right, we'll have performed the operation. So if I look at the a squared terms, I have 8a squared plus 3a squared. 8 plus 3 is 11. A squared. I look at the AB terms, right? Negative 7 plus 4 is negative 3ab. And then I look at the b squared terms. I have positive 2 plus negative 7, which is negative 5b squared. And that's it. Nothing to it. When you're adding polynomials together, it couldn't be easier. Okay. The next one is also addition. So you just got to be careful with the powers, right? There's, the powers here could be a little messy, so you just got to be careful with the powers. So this term right here contains m to the 4th p. All right. Now if I look, I am adding. All right, so I don't have to worry about signs so much. But I want to look for another term that has m to the 4th p. Right? That's what I want to look for. So m to the 4th p. Is there any terms around there that are like that? Well, if you look, there are no other terms that are m to the 4th p. There aren't any. This is the only one like it. So I'm just going to write that down as it is, because there are no other like terms like this. All right. My camera is being uncooperative. Here's an m cubed p squared. Here's another m cubed p squared. So I have 2 of them. The coefficients on them are 1, so that means I literally have 2 of them. 1 plus 1 is 2. So that means I have plus 2 m cubed p squared. All right. This is an m squared p cubed. Here's another m squared p cubed. So this one and this one are like terms. Now if I look at their coefficients, this is negative 7 and positive 7, so that gives you 0. So technically, when you add these two together, they don't show up in the final result. They just don't show up. So I don't have to worry about writing anything for that one. And finally, this is the last term. So I don't have any mp cubes here. So it's essentially adding 0 to this. So it's 0 plus negative 8 mp cubed is just negative 8 mp cubed. And that's it. All right. Just remember, when you're adding polynomials, you're adding like terms. You're adding their coefficients together. You are not adding their exponents. You're not adding your exponents. The only time you add exponents is when you multiply. All right. Now this is subtraction. So what I need to do before I start combining like terms is since I'm subtracting this whole term, I need to distribute the negative. The negative must be distributed to every term in the second polynomial. So let me rewrite everything. So I have 8m squared plus 3mp minus 5p squared. When I distribute a negative to a negative, that becomes a positive. 2m squared, negative times a negative is another positive, that's positive 7mp. A negative times another negative is another positive, that's 4p squared. So now I can combine like terms, like I did in the first two problems. So here's an 8m squared, here's a 2m squared, and those are the only m squared terms, so they combine to be 10m squared. Okay, here's a 3mp, and here's a 7mp. Plus 3 plus 7 is plus 10 mp. Okay, and then here's a minus 5p squared and a plus 4p squared. So minus 5 plus 4 is minus 1, which I could just write minus p squared. And that's it. There are no more terms left to combine, so that's the result. It's worth noting that this is a quadratic in two variables. It's a quadratic in terms of m, and p is the coefficient, along with the 10. Okay. Letter D is also subtraction, so we want to distribute the negative. It's the same kind of process as as letter C. So the first polynomial and now distribute the negative, so this makes this minus 5a squared b squared. Minus times a minus is a plus 7a b cubed, and then minus times a positive is a negative b cubed. Alright, now I could combine like terms together again. So here's an a cubed b. Do I have any more a cubed b's? So it does not look like it. I do not have any more a cubed b's. I don't have any a cubed times b anywhere else. So that's the only a cubed times b term. So let me just bring it down. Now I have a squared b squared term and another a squared b squared term. So I have minus 5 plus minus 5, which was negative 10 a squared b squared. That is a 1ab cubed, and this is a 7ab cubed. 1 plus 7 is 8 ab cubed. And then the last term, the only term like it, is this one, minus b cubed. And that's it. So when you're subtracting polynomials, you just got to make sure that you distribute the negative to the second polynomial. That's all you got to do. And then it's the same as adding them. Just combine the coefficients together. Okay, the next page. So we're still performing operations. But now the operation here is multiplication, right? Because I don't have anything between the term and the parentheses, so that implies multiplication. So in letter A, you're just going to distribute this term to all three of these terms inside the parentheses. So when you do that, this times this is going to give you, so negative 7 times 6 is negative 42. W squared times w squared, that's going to be w to the 2 plus 2 power, which is w to the 4th power. And y times a term with no y in it is just y times 1, which is just y. That's the first product. Here's the next product. So negative 7 times 2 is negative 12. Y squared times y is y cubed. Y times y is y squared. And then the third product is negative 7 times negative 8 is positive 56. Y squared times a term with no y is just y squared. Or, I'm sorry, w squared. I meant to say w squared. And then y times y squared is y cubed. My camera keeps going in and out of focus. So that's it. I'm trying to calibrate it, but it's being difficult. So I apologize if it comes in or out of focus, but I will do my best. You know, all you're doing is performing the indicated operation. You're not solving for anything. You're just performing the operation, whether it's addition, subtraction, multiplication, or division. The only time you're going to solve for something is if you have an equal sign. You don't see any equal signs here, so you're not solving for anything. Okay, in letter B, I have a binomial times a binomial, so we're going to use FOIL. All right, so the first, outside, inside, last. All right. Okay, so the first terms are 2a squared times 7a squared, which is going to be 14a to the 4th power. The outside is going to be 2a squared times 3b squared. So 2 times 3 is 6. A squared times b squared is just a squared b squared. All right, the inside is negative 5 times 7, which is negative 35. B squared times a squared, which is the same thing as a squared b squared. And then the last. So negative 5 times positive 3 is negative 15. B squared times b squared is b to the 4th. All right, so since I foiled it, I'm not quite done yet because these two middle terms are like terms. Those are a squared b squared terms, so I can combine their coefficients together. And when I do that, I get 14a to the 4th. So plus 6 minus 35 is what? Simple arithmetic. That's going to be negative. So take 6 away from that. And it's going to be negative 29. I think so. Let me check. For some reason, I can't do simple math tonight. Yep, I was correct. Negative 29. A squared, b squared, minus 15b to the 4th. Now I am done. There's no more terms to combine, so that's the product. All right, letter C is 3p plus 7t quantity squared. So remember, do not do this. This is a common mistake I see students do. Do not write this. I see that mistake often, and it's not correct. You're not going to square that, and then you're probably thinking, all right, well now I'm going to have 6. 3 squared is 9, p squared, plus, and 7 squared is 49, t squared, and then I'm done, right? No. You cannot do it that way. That is not correct. Do not do this problem that way. You have to write this out term by term. The power 2 means I have 2 factors of 3p plus 7t. So what I really have is 3p plus 7t times 3p plus 7t. And now when you multiply this, so basically what I'm saying is I have two binomials. And how do I multiply two binomials? I just did it right here. You FOIL it. And you'll see in a minute that when I FOIL this, it'll be nothing like that, which is just, that's just incorrect. Those are not equal. Do not do that. So FOIL here, so 3p times 3p is 9p squared. 3p times 7t is 21pt. The inside, so 7 times 3 is another 21 tp, which is the same thing as pt. Plus, and then the last, 7t times 7t is 49t squared. And now I can combine the two middle terms together to get 9p squared. When you combine those two together, you're going to get 21 plus 21 is 42 pt plus 49 t squared. So that is the correct multiplication. That's the correct product. If you looked here, you're missing a term. Yeah, you got these two, but you're missing the 42 pt in the middle. And that's what happens when you break this up like that, which you cannot do. That does not work. The only time you can break up powers is if you have a product or division. You cannot break up powers or square roots for that matter when you have addition or subtraction, because they follow the properties of exponents. That's why. Letter D was the only kind of division problem we looked at in this course. So whenever you have a single term in the denominator, you could just break up every term in the numerator over that common denominator and then just simplify each mini fraction. So I could write this as 20 p to the 9th over 5 p cubed minus 5 p to the 6th over 5 p cubed plus 15 p cubed over 5p cubed. And now I could just simplify each fraction separately. So 20 over 5 is obviously 4. P to the 9th over p to the 3rd, that's a property where you subtract the exponents. That'll be p to the 6th. Minus 5 over 5 is 1, so it has a coefficient of 1. I don't have to write that. P to the 6th over p to the 3rd is 6 minus 3 is 3, so that's going to be p to the 3rd, p cubed. And then plus 15 over 5 is 3. P to the 3rd over p to the 3rd, well, they're the same, so they just cancel out completely, so I just have 3 left. And that's it. That's it, nothing to it. Alright, next page. So on page 3, we're looking at the factoring techniques. So remember, you have all those factoring techniques that you got to do. And you have to keep them in your mind when you're factoring, when you see a polynomial. Now in letter A, it's always a good habit to check to see if a GCF exists, right? If there is no GCF, then you would go and check the other methods. Is it a quadratic? Should I use the AC method? Is it a 4-term polynomial? Should I use grouping? Whatever. Now in letter A, this is obvious. There is no GCF, but this is a quadratic. You should be able to recognize that by now. So you should use the AC method. Now you could use the AC method by grouping or by trial and error. Since the coefficient here is 1, trial and error will be the easiest. So, alright, the coefficient here is 1. The factors of 1 are 1 and 1, obviously. The factors of 25 are 1 and 25, and 5 and 5. So here's a pair of possibilities, and here's another pair of possibilities. Now, since my leading coefficient, that's no good, it's better. Since my leading coefficient was, hold on, give me a second, I'm trying to adjust this. Alright, that looks a little bit better. Hopefully that records better. That might be a little choppy. Hold on. Yeah, I'll just have to manage it. Okay. So since my leading coefficient is 1, right, that does not mean I have an extra pair of possibilities for each pair. I don't have an extra combination. I don't have to flip the C values. So I just have one factor for each pair. All right. So the first factor is, since it's 1 and 1, I'm going to have x and x and x and x. The first pair of C's is 1 and 25. And again, there's no need to flip that because my leading coefficient was 1. And then the next pair of C's is 5 and 5. Now, I just have to check to see which outside-inside pairs is going to give me positive 10. And it should be pretty obvious that these two work, right? The outside here is 5x, the inside here is 5x. That obviously adds up to be 10x. And the way that adds up to be 10x is I have positive 5x and positive 5x. So that means this is positive and this is positive. And then finally, you just check. Is 5 times 5 25? Obviously it is. So those are my factors. X plus 5 times x plus 5. That's it. Letter B. Now, if you remember, well, there is no GCF. There's no GCF. Okay. So I could rule that out. Now, you have to be able to recognize that this is a quadratic in two variables. Right? It's a quadratic in two variables. Don't just assume that because there's no GCF that it's prime. Okay? Don't assume that because it could probably factor. It's a quadratic in two variables, so I need to check. So I'm going to rewrite this as a squared plus, so since the variable in this is a, right, the b variable is also part of the coefficient. So I'm going to write the b with the 12. I'm going to write this as 12ba plus 20b squared. So my coefficient here is, my leading coefficient is 1. My b coefficient is 12b. And my c, my constant, is the whole term 20b squared. That's my a, that's my b, and that's my c. That's an A, by the way. Alright, so now you could choose to do this, since it's a quadratic at two variables, you're going to use the AC method because it's a quadratic. You could choose to do it with trial and error or factor by grouping with the AC method. Well, the leading coefficient is 1, so we could probably get away with trial and error. We could probably do it that way. And just because I'm doing it that way does not mean you have to do it that way. All right. So the factors of 1 are 1 times 1. And for now here, I'm going to just list the factors of 20, and then I'm going to tack on a b to each one, to each factor. So my factors of 20 are 1 and 20, 2 and 10, 4 and 5. I think that's it. Now, this is 20b squared, so really both of these factors have a b on them. So that's 1b times 20b. This is 2b times 10b. And this is 4b times 5b. So there's one pair, there's a second pair, and there's a third pair. Now, since my leading coefficient was 1, I don't have to flip an extra pair around. I just have one combination for each pair, which is nice. I don't have an extra pair to consider I don't have an extra combo to consider. So the first terms in each one are going to be 1a times 1a, which I could just write as a times a times a times a. This one will be 1b and 20b. So b 20b, 2b and 10b, and then 4b and 5b. Now, I just got to find the 1. When I do outside inside, I get 12ab. Right? And you should be able to see pretty quickly that the middle one looks promising, right? The outside here, a times 10b is, right? The outside here is 10ab. The inside, 2b times a, is 2ab. I need 12ab. For that to work, both of them need to be positive. Positive there, positive there. The last thing I need to check is if 2b times 10b is 20b squared, which it is. So those are my factors. A plus 2b times a plus 10b. That's it. Nothing to it. And if you're not convinced, you could always FOIL this out and you'll get back what you started with. Because factoring is the opposite of operations. Okay. Letter C. So, it's pretty obvious there's a GCF here. Right? So, the factor that goes into 5, 40, and 80 is going to be 5, right? And they all have at least one k in common. But there's also one more thing you got to be aware of. The leading coefficient here is negative. We want it to be positive. So I'm going to make the GCF negative. So my GCF is negative 5k. So when I factor that out, I'm left with, so negative 5k out of negative 5k to the third is going to be positive k squared. Negative out of a positive, so when a negative times a negative is going to give me a positive, so this next term will be negative. When I factor 5 out of 40, I get 8. Negative 5 times negative 8 is positive 40. K factored out of k squared is k. Negative out of negative, so negative times a positive gives me a negative, right? 5 factored out of 80 is what? Simple arithmetic, I think it's 16, isn't it? And I am correct. And when you factor k out of k, there's just 1 left, so that's it. When you factor the GCF out of that, that's what you're left over. That's what you're left with. Now you're not done. You have to recognize that this is a quadratic. That is a quadratic. And since the leading coefficient of this quadratic is just 1, I could just do trial and error. So the 1 here gives me factors of 1 and 1. Factors of 16 are 1 and 16. 2 and 8. 4 and 4. There's a pair. there's a pair, there's a pair. And since the leading coefficient is 1, I don't have to flip the C's. I just have 3 combos. That's it. So this one is going to be 1k times 1k, so that's k times k, k and k, k and k, 1 and 16, 2 and 8, 4 and 4. Now, which one is going to give me negative 8k? So the first one doesn't look good. The second one doesn't look too good either. This one looks good. So the outside, inside here, that's going to be 4k and 4k, and I could definitely get, I need to get negative 8k. In order for that to work, they both need to be negative. But the last thing you got to do is check if the C's give you what you started with, your initial C. Negative 4 times negative 4 is positive 16, so boom, that works. So this quadratic factors to be these two binomials. So the whole polynomial factors to be negative 5k times k minus 4 times k minus 4. And that's it. So don't just think you're done by factoring one time. You know, your factors could also factor, which this one did. Now, in letter D, there is no GCF for the whole thing right off the bat. But this is a 4-term polynomial, so factor by grouping. All right, you should do factor by grouping. So the GCF in the first two, and then the GCF in the second two. So the GCF here is going to be what? They have an a squared in common. I think that's it. Now the GCF in the second two, you got to be careful here. So the leading coefficient, if you just look at the second two, the leading coefficient there is negative. So I know my GCF will have to be negative. And they have a 2 in common and a b in common. All right. So when I factor that out, I have a squared times the first group minus 2b times the second group. A squared out of a squared x means there's an x left over. A squared out of this means there's a minus 3y left over. Okay. Minus 2b out of this, so that's going to be positive, right? Because this is negative. And there's just going to be an x there, I believe. All right. You know, if you distribute this with this, you'll get that. So that's how you check it. A negative out of a positive is another negative. 2 out of 6 is 3. And there's just a y. So hey, look at that. Now I could see the whole thing that this binomial x minus 3y is the GCF. So I could factor that out of the whole thing. All right, when I factor this out of the first two, I'm going to get a squared left over. And when I factor this out of the second group, I have minus 2b left over. And since neither this one doesn't factor anymore and this one doesn't factor anymore, I am done. This one, you know, it's worth noting that you might think this is a difference of 2 squares because the first term is being squared, but it's a subtraction, but this is not a perfect square. So that is not a difference of 2 squares, but it's just worth noting that. All right. The next page. So a few more factoring techniques. So letter E is a quadratic. There is no GCF there. You know, 7, 24, or 9, they don't have a GCF. But that is a quadratic. So you're going to use the AC method. Now, if I look at the values of A, B, and C here, you know, they are kind of big. They are kind of big. And so really, but the good thing though is that the number 7 is a prime number. So the only factors of 7 are 1 and 7. So even though they are big numbers, I could probably still get away with trial and error. But if you did want to do this with grouping, you could certainly do it that way. You already know that I just prefer trial and error. That's just my personal feelings towards it. Alright, so the factors of 7 are 1 and 7. And that's nice because that only gives you one pair there. The factors of 9 are 1 and 9. And 3 and 3. So there really isn't that many. I just have 2 pairs. But since my leading coefficient here is not 1, I have an extra combination to consider. So actually each pair gives me 2 factors, right? This one's going to give me 2, 1, 2. And then this pair is going to give me another 2, 1, 2. So I have 4 different, you know, combos to consider here. So this one will be x and 7x. And then I have a 1 and a 9. But then I got to flip it, a 9 and a 1. Then in the next one I have a 3 and a 3. And if I flip the 3 and a 3, I still get a 3 and a 3. So actually, remember I said this in your notes, sometimes you'll get a duplicate case, and that's what happened here. This is a duplicate. So I could just get rid of one of them. So really I only have 3 to check. Alright. Now the ones I have to, so really I just got to check to see which one gives me negative 24x. Okay. 9x, 7x, that doesn't give me 24, that gives me 16. 1x, 9 times 7 is 63, that's nowhere near what I need. That's 3x. Alright, that right there is 3x. This right here, 3 times 7x, that's 21x. Hey, that looks nice. That'll give me negative 24x. Right? And that'll only give me negative 24x if both of them are negative. Right? So that's a negative, and that's a negative. And then the final thing I need to check is if negative 3 times negative 3 is positive 9. It is. Good. So that's beautiful. My factors or x minus 3 times 7x minus 3. And that's it. So just because you have big numbers here doesn't always mean it's going to trial and error will be bad. It depends how, big numbers are bad, but if they're not prime numbers, then yeah, you should probably do trial and error with grouping. 7's a prime number, so I only get one factor of that. The more factors you get here, the worse the trial and error method will, well, the more combinations you have to consider. Alright, letter F. So there is no GCF between 25 and 16. Now this is a difference, and it's a binomial. It's pretty obvious that x is squared here, so you're probably thinking this is a difference of squares, and it is. So a difference of 2 squares here, that's what I got. So we already know, 25 and 16, those are perfect squares, right? 5 squared is 25, and 4 squared is 16. And I don't know why my camera keeps coming out of focus. I really don't. x is obviously squared, so I have a difference of 2 squares. So this factors pretty easily. We know that the binomial factors are plus and minus in the middle. So the two terms multiplied to give me 25x squared are going to be 5 and 5, and x and x. And the two numbers that give me 16 are 4 times 4. And that is it. That's it. Easy peasy. Difference of 2 squares. Pretty quick. Pretty efficient. Okay. Letter G. Now, this is a binomial being added. I have an x to the cubed power. So this is a good indication it's a sum of cubes. That's a sum of cubes. And if you remember, now this one, the factors of the sum of cubes are a little bit more, complicated. But just remember, a sum of cubes factors to be the following. If I have a cubed plus b cubed, I get a linear factor and a quadratic factor. The signs, so the first signs match. So if I have a sum of cubes, this one's the same. This one is always going to be addition, and this one's negative. That's a sum of cubes. Okay? This one is always positive. For a difference or sum of cubes, that one's always positive. This one matches the term you have here. So if it's a sum of cubes, that's plus. If it's a difference of cubes, that's negative. And then this just alternates. If this one's positive, that one's negative. This one's negative, that one's positive. But this one is always positive. So you could think of it as plus minus plus or minus plus plus. Alright. So we know this is a sum of cubes because 2 to the third power is 8. And 3 to the third power is 27. 8 and 27 are perfect cubes. So my factors are going to be the linear term and the quadratic term. So a plus b, well, we already know 2 to the third is 8, so a is going to be 2. And it has an x to the third, so it's going to be 2x altogether. Plus, the number cubed that gives me 27, we know is 3. So my a plus b term is 2x plus 3. A squared is going to be the number that was, so the a value here would be 2, right? So a squared is going to be 4. A was 2x, right? So it's going to be 4x squared. All right, just think of it this way if you're not certain. A cubed here was 8x cubed. All right? B cubed here was 27. So that implies that if a cubed is 8x cubed, then a is going to be 2x. And if b cubed was 27, that implies b is going to be 3. So there's my a plus b factor, 2x plus 3. A squared is going to be this whole thing squared, which is 4x squared, minus a times b. So that's going to be 2x times 3, which is 6x, plus b squared. 3 squared is 9, so that will be plus 9. So this factors to be these two. Now this is a quadratic. This is a quadratic. So you do have to check to see if it factors. You do have to check to see if it factors. Now, Since my leading term is a 4, I'm going to have 1 times 4 and 2 times 2. And then with 9, I'm going to have 1 times 3 and then, or I'm sorry, 1 times 9 and 3 times 3. So I'm going to get, and then I'm going to have to flip them. So I'm going to have 4, I'm going to have 8 different possibilities. That's a lot. So I will do the AC method with grouping here. That's what I will do. So remember, the AC method with grouping is A is 4, C is 9. So A times C is 36. So the factors of 36 are 1 and 36. 2 and what? 2 goes into 36. If you need your calculator, you could do it. 36 divided by 2 is 18. Does 3 go into 36? It does, 12 times. 36 divided by 4 is 9. And I think that's it. No, wait, 6 times 6. That's it. Now, this is, these are the numbers that multiply together to give me 36, right? But I could also multiply 2 negatives together to get me 36. So not only are these my factors, but also they're negative values. So I have negative 1 times 36, negative 2 times negative 18. And I'm considering the negative values because if I look at my quadratic, my middle term is negative. That's why I'm considering it. Okay. So really, I really don't care about the positive ones because my middle term is negative 6x. Which one of these are going to add together to give me negative 6? Any of them? So negative 3 plus negative 12 is negative 15. That's negative 13. That's negative 12. Negative 20, negative, yeah. So none of these are going to work. None work. None work. So what does that mean about this quadratic? It doesn't factor. So since none work, this is prime. So this is in fact my factors. 2x plus 3 times 4x squared minus 6x plus 9. It doesn't factor. You should always make sure that you check to see if you factor a sum of cubes, you should always check to see if the quadratic in that factor does indeed factor. Don't just assume it's going to be, don't just assume it's going to be prime. Okay. So now we're going to look at solving polynomial equations using, our factoring techniques, right? So now we have an equal sign in here. So we're solving for x. This is a quadratic, so you're going to use the AC method. Okay, 1 times 1, 1 times 15, 3 times 5. I don't have to flip them because my leading coefficient is 1. X and x. That looks ugly. Sorry about that. One and 15, 3 and 5. Now, which ones are going to give me negative 8? Looks like this one. So the outside here is 5x. The inside is 3x. I need to get negative 8x. So the only way that works is if they're both negative. Negative and negative. And since negative 3 times negative 5 is positive 15, those are my factors. So this quadratic equation becomes x minus 3 times x minus 5 equals 0. So I could set each factor equal to 0 and solve for x. So add 3, you're going to get x equals 3 or x equals 5. So my solution set is going to be 3, 5. And you should check your solutions in your calculator by storing them in your calculator. So it's 3 store into x. Type in the original quadratic, which is x squared minus 8x plus 15, and that gives me 0. Then you can also check 5. 5 store x, second enter, hit enter, and I get 0. So I know they work. Okay, next page. So here's a few more quadratic equations. So in letter B, I could factor a GCF out of that. So the highest number that goes into 8, 12, and 20. Well, I could do that thing in my calculator, math, number, GCD. So 8, 12 is 4. And then if I do that again, between 4 and 20, I also get 4. Okay, so my GCF is 4, and they have an x in common, so let me factor that out. So 4x factored out of 8x cubed is 2x squared. 4x out of negative 12x squared is negative 3x. Then 4 out of negative 20x, or 4x out of negative 20x is negative 5. So that whole thing equals 0. Right? Okay, I'm not done factoring yet, because you can tell that this is a quadratic. I will use the AC method for trial and error. Okay, so my factors are 1 times 2 and 1 times 5. Okay, now since my leading coefficient is not 1, I have 2 combinations, 1 and 2. Alright, so the first combination is x, 2x, x, 2x, then I have 1 and 5, and 5 and 1. So which ones are going to give me negative 3x? Potentially. So it looks like the first one, right? That's 5x. Right, that right there is 5x. This right here is 2x. To get negative 3x, the 5x would be negative, the 2x would be positive. So that one would be negative, the 2x would be positive. And since negative 1, since positive 1 times negative 5 is in fact negative 5, that works. That does work. So my factors are 4x times x plus 1 times 2x minus 5 equals 0. So those are all my factors. So I could set each factor equal to 0. So 4x equals 0, or x plus 1 equals 0, or 2x minus 5 equals 0, which means when I divide both sides by 4, 0 divided by 4 is just 0. Subtract 1, x equals negative 1. Add 5, so I get 2x equals 5. Divide by 2, x is going to equal 5 halves. So my solution set is going to be, now technically you should write your values in your solution set from least to greatest. You don't have to, but technically that is the way to do it. So negative 1, comma 0, comma 5 halves. Now, you should check it. 0 is obviously easy to check. 0 minus 0 minus 0 is 0. That's easy. Store negative 1 in. Let me just do one of them. Negative 1, store x. Oop. Alright. Type in the polynomial 8x cubed minus 12x squared minus 20x gives me 0. Boom. And then the other value was what? 5 halves? I might as well do it. Second enter, and I hit enter again, I get 0. Boom. Letter C is right here. Now again, your right side of your equation must equal 0. So since it's not equal to 0, I got to subtract 4. Now I could factor. Now, they do have a GCF of 4 technically. So when I factor that out, I get 4 times what? X squared minus 1. And this right here is a difference of 2 squares. So when you factor that, you're going to get 4 times x minus 1 times x plus 1. I don't care about the 4 here because 4 doesn't contain. You're not going to set 4 equal to 0. That's silly. You're not going to do that. So you could just divide both sides by 4 to get rid of it. You're going to be left with x minus 1 times x plus 1 equals 0. That's easy enough. That means x minus 1 equals 0, or x plus 1 equals 0, which means x equals 1, or x equals negative 1, which means my solution set are the values negative 1, comma 1. Letter D. Again, the right side is not 0, so you have to bring the 24 over. Now, before you could bring the 24 over right now and then foil this, or you could foil this and then bring the 24 over. The order you do it is irrelevant, just as long as you bring 24 over. I'm going to foil this right now. And the reason I'm foiling it is because I have to combine like terms. Since the right side is not 0, I have to combine that 24 with the values in this product. So I have to FOIL it out. So when you FOIL out, you're going to get x squared minus 2x plus 3x minus 6 equals 24. Now you could see how I could combine like terms with the negative 6. So if I subtract 24 now from both sides, that right side becomes 0. So the left side is x squared minus 2x plus 3x is plus x. Negative 6 minus 24 is negative 30 equals 0. So now this is my quadratic. Now I can factor that. You're probably wondering, you're probably thinking, well, wait a minute, why should I factor that when we already had it factored? Again, this quadratic is not this quadratic. All right, this quadratic FOIL out is x squared plus x minus 6, but I have to combine the 24 with it to get this quadratic. You have to make your right side equal to 0. So when you factor this, that should be easy enough. 1 times 1, and what? The factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. So, you know, just to save time here, it looks like the last one's going to give me the factors I need. And I don't have to flip the pairs because my leading coefficient is 1 here. So I have x and 5 and 6. All right. The outside, inside, I must get positive x. All right. So the outside here is 6x. The inside here is 5x. I need plus x. So for that to work, the 6x must be positive, the 5x must be negative. So that's going to be positive, that's going to be negative. And since negative 5 times positive 6 is negative 30, those are my factors. All right. So my equation becomes x minus 5 times x plus 6 equals 0. Set each factor equal to 0. Add 5. I get x equals 5. Subtract 6. I get x equals negative 6. My solution set is the values negative 6, comma 5. Check it. Negative 6, store x. Type in the original polynomial. X plus 3 times x minus 2. When I hit enter, I should get 24. Look at that. Let me try 5. 5, store in x. Second enter, and I hit enter again, I get 24. Beautiful. Nothing to it. Make the right side 0. Last page. All right, the last page. So these are the various topics on the chapter 11 stuff. Those two sections in chapter 11. So 11.1, we've looked at absolute value equations. So to solve this, remember, you have to make sure that the whole thing, that this is isolated before you apply this property. All right, I just have to have absolute value of x, or a, I mean, to get a equals k and a equals negative. Oh, I wrote that in the opposite order. To get a equals negative k. All right. So I have to add the 4 before I do that. When I do that, I get the absolute value of 2x minus 3. I hate it when my camera screws with me. Equals what? 3 plus 4 is 7. So now that I have just absolute value of stuff on the left side, now I could do this. And when I do it, I get 2x minus 3 equals 7. And 2x minus 3 equals negative 7. Now solve each equation separately. So add 3. 2x equals 10. Divide both sides by 2. X equals 5. And add 3. 2x negative 7 plus 3 is negative 4. Divide by 2. X equals negative 2. All right, well, that looks easy enough. So remember, make sure you check it before you make your solution set. With absolute value equations, you have to check your solutions. So negative 2, store in the x. Type in the absolute value, so math, number, ABS, 2x minus 3 minus 4 gives me 3. Beautiful. That one works. 5 stored in x. Second enter, second enter. That also gives me 3. Beautiful. So my solution set is -2, 5. Letter B. So since I have the desired form, I could just do this right off the bat. So I could just do this and get -2x plus 7 equals 25, and -2x plus 7 equals -25. Add 7 to both sides. -2x 25 plus 7. Last time I checked, that was 32. Divide both sides by -2. -32 divided by -2 is negative what? 16. All right. Next equation. Oh, wait a minute. I screwed this up, didn't I? Yeah, I did. I'm sorry. I had positive 7 here. I had to subtract 7. I'm sorry, guys. That's what happens when you record these things late at night. Let me go back. Subtract 7. Right, because I have plus 7. That gets rid of that. That's better. So I have -2x 25 minus 7 is 18. Divide by -2. So that means x equals, so 18 divided by -2 is -9. That looks a little better. Subtract 7 from both sides. So I have -2x equals, so -25 minus 7 is -32. Divide both sides by -2. That is positive 16. Alright, that looks better. So my solution set I have to check them. So let's do it. So -9 stored in x. Type in the original equation. So math number ABS. -2x plus 7. Hit enter and I get 25. Beautiful. The next value is 16. Store that in x. Type in the original equation. Second enter, hit enter again, and I get 25. That works too. Beautiful. So my solution set is -9, 16. Sorry about that. I got a little ahead of myself. Now, just because I don't have a problem like this on here, remember this problem? Something like this, the absolute value of A equals the absolute value of B. I could have something like that on your test. Just because I don't put it here doesn't mean it won't show up. That's the same thing goes for this problem. Like, you know, I could ask you a Pythagorean theorem problem. I could ask you an equation of a circle problem. But, you know, I could ask you those problems. But that is possible. Just because I have it on here doesn't mean I will ask it. And just because you don't see it on here doesn't mean I won't ask it. So find the distance between 2 points. All right, do not confuse distance with slope. Remember, the distance formula is the quantity y2 minus y1 squared plus x2 minus x1 squared. And the nice thing about the distance formula is if you wrote it the opposite way, if If you wrote it like this, flipped around, you'll still get the same thing because they're squared. Well, they're being added, so. So this is the first order pair, so that's x1, y1. And that's x2, y2. So y2 is 2 minus y1, which is 4. That whole quantity is squared. Plus x2 is 2 minus x1, which is 3. That whole quantity is squared. 2 minus 4 is negative 2 squared, plus 2 minus 3 is negative 1 squared. Remember, you cannot break up a square root with a sum. Negative 2 squared is 4, plus negative 1 squared is 1. So I have the square root of 4 plus 1, which is the square root of 5. If you approximate that in your calculator, second square root 5, that's roughly 1, that's 2.24 units, roughly. That's why I put an approximate here. But you could just leave it like that or approximate it if I tell you. But that's the distance. And that's it. And I could ask you, I could ask you Pythagorean theorem question. I could ask you an equation of a circle problem. But yeah, that's the end of the exam 3 review. Hopefully that was helpful to you. But yeah, so that's the end of the review. That's the end of the video.